Okay, example 2. Prove that the measures of the external angle of a triangle equals the sum of the measures of the remote interior angles. What I've done here is I've done sort of a skeleton proof for you. I've done pieces of it in there for you. So you don't have to think through every last little detail of this. But it's going to help you to establish what to do. First thing is a couple words, external or exterior angle of a triangle. Anytime you have a polygon and you extend a side of the polygon to create an angle outside the polygon, that's called an external angle or exterior angle. In this case, angle D is an external angle. And what we're trying to prove today is that that angle there, that measure of that angle, is equivalent to the remote interior angles. Interior angles are inside the triangle. Hopefully that makes sense to everybody. Interior means inside, right? So interior angles inside. The word remote might be not as familiar to you. You've heard of remote control, right? What does remote control do?
Control something far away.
Control something from far away. So like when I use my remote control here to turn on and off my projector, I'm standing over here, projector's over there, I can stand far away from it and control it. If I'm on a remote island, I'm out in an island far away from everybody, hopefully with some way of getting off the remote island, or a good food source or the other. Alright, so if we're looking at interior angles, A, B, and C, the remote interior angles are the ones that are far away from angle D. So angle D is right next to angle C, but A and B are far away. So what we're trying to prove here is that angle A plus angle B is equal to angle D. That is a fact. That actually is true, but we need to prove it. That's not something that's just a postulate truth. That's not obviously they're the same. All right, but we have to prove it. Yes, Brady?
All these, every time we have something like this, they're always going to be true.
Yeah, if they ask you to prove something, they're not going to ask you something that's not true.
Yeah.
And it's actually, if they ask you to prove something that's not true, you prove it not true by a counterexample. If they say this is always true, and you say, well, if this is the case, then it isn't. Okay, and you guys are experts at that. Teenagers are experts at disproving things. You never clean your room. Well, on April 27th, you might recall that I cleaned my room. You see, so teenagers are experts at disproving things. But again, if they give you a proof in the book, it should be something that you know. That's something that is true and that can be proven. They're not going to ask you to prove stuff that isn't true. All right. So that's what we're trying to prove, is that these two angles add up to that angle, and again, that is true. All right. So here we go. First thing I stated is that A, B, and C equals 180. Remember what I said yesterday on Wednesday about proof. If you're trying to prove an equation, if you're trying to prove something equals something, you have to get the components of the equation into equations, maybe not in the same equation. So I know A and B have to get in an equation, so I look at A and B and ask myself, is there anything true about A and B with anything that it has to be true that I already know? And A, B, and C, the three angles inside a triangle, have to add up to 180, right? So that's what I did. A, B, and C add up to 180 because there's 180 degrees in a triangle. It's officially called the angle sum theorem, if you want to go there. I'm fine with that. There's 180 degrees in a triangle. If you can't remember the name of the theorem, just tell me what you know to be true. A, B, and C equal 180 because I know there's 180 degrees in a triangle. All right. Next reason, notice I say straight line. So where's the straight line at?
C and D make a straight line.
Right here. C and D make a straight line. So there's my straight line. There's my line there. C and D together make the straight line. So step 2, angle C plus angle D is equal to 180 degrees because they're in a straight line. 180 degrees in a straight line, if you will. All right. So my first statement got me A and B into an equation. My second statement got me D into the equation. Once I get all my components of my equation into some equation, now I look for some way to combine those equations together. Our substitution postulate, which is postulate 6, the one that says, I think if equals be equal to equals or something like that. The wording of equals is weird, but it says if two things are equal to the same thing, they're equal to each other. That's what it says. If two things are equal to the same thing, they're equal to each other. I had to probe my memory banks there. Notice that A, B, and C equal 180. C and D add up to 180. All right, so if two things are equal to the same thing, then the two things are equal to each other. That's postulate 6. So I've got these two equations up here. They both equal 180. So for statement 3, to use postulate 6, whatever things are equal to the same things, I'm going to say these two things equal each other. That's going to be statement 3. So I'm going to go statement 3, measure of angle A plus measure of angle B plus measure of angle C equals measure of angle C plus measure of angle D. If this said dog equals 180, this said cat equals 180, this would say dog equals cat. Again, it doesn't matter what these things are, the fact they're both equal to the same thing. If I'm using postulate 6, these two things are equal to each other. That's how we create that. And the power of postulate 6 is that this had part of the problem in it, this had part of the problem in it that I'm trying to prove, right? That got them into the same equation. So now A, B, and D are in the same equation, but now we continue looking at this and we notice that we have an angle C and another angle C. Okay, thankfully those are the same thing. They don't have to be, but they are, okay? We have those things that are getting in the way of what we're trying to say. I want to say that this plus this equals that. The angle C's are in the way. And what I notice is that angle C is on both sides the same, so I'm allowed to subtract angle C from both sides. Notice angle C equals angle C, right? If equals be subtracted from equals, the remainders are equal. That's the postulate, right? That's postulate 8 if you wish to know it. If you wanted to say subtraction property of equality, if you don't remember it's postulate 8, that's fine. That's the subtraction property of equality. You subtract the same amount from both sides, that's the official name of it. Alright, if I were to do this, C minus C cancels, C minus C cancels. I'm left with A plus B equals D, which we're trying to prove. And the reason for that is simply simplification. Simplified, maybe. If you do any kind of algebraic simplification, angle C minus angle C cancels, that kind of stuff, then it's just simplified would be the reason for that. Alright? Again, that proof might show up on a test. Okay? That other proof we did the other day, vertical angles are equal, that proof might be on a test. Okay? Any proof we've seen in class could be on a test. I'm not going to throw some new proof at you on a test. Alright? But just be able to think through it, understand it. Okay? When it comes time to do a proof on a test, I'll say we're going to do a proof on the test. I'm not going to tell you which one. But just know it'll be one that you've seen before. So you should be able to handle it.